Thank you for joining us. This is your ParkerWeather.info October 24th, 2010 update. Well, what is now Hurricane Richard has moved off the Belizean coast and is about to make landfall with sustained winds of 90 miles an hour, moving northwest at 13 with a minimized central pressure of 981 millibars as it moves over Belize, northern Guatemala into Mexico and the southern Yucatan Peninsula. Well, a lot of the models are pretty much agreeing on one specific track, whether it's farther into Guatemala or more northern into Mexico. It really isn't clear, but it looks like they're all going to take the same general track into the Bay of Campeche. So here is our current AVN loop of the storm. And one thing that we're really going to be looking at is these bands out ahead of Richard. And once those move into that warm water of the Bay of Campeche, those could develop into pretty strong storms and take a lot of the inflow that Richard needs to survive, and this storm could die off pretty quickly, a lot more quickly than some people think. And here is our current visible. As you see, it is about to make landfall on the Belizean coastline, affecting northern Guatemala, Yucatan Peninsula, bringing heavy rains and flooding to that entire area. And here's our current radar from the Philip Goldston Airport in Belize. You can see the well-defined eye on the radar imagery as heavy rains and wind are pummeling the Belizean coastline. So one thing that Richard does not have going for it is as it moves more north, it will be moving into an area of greater shear. So anything under 20 is optimal for tropical development, and it looks like it's in an area of about 10 knots of shear. But as it continues to move to the northwest, it's going to be going into areas of 20 to 25 to 30 to even 40. And if we look at our next shear indices, you can even see a contour of 60 knots of shear. So that's the one thing working against Richard as it continues to move over the Yucatan Peninsula, Belize, and Guatemala. So here are a couple of screenshots of some webcams just off the Belizean coast. You can see the palm tree on the right. Looks like it's getting hit pretty heavily with those sustained winds as the storm comes on. And same goes for the next webcam as the heavy rains and wind are finally moving into the Belizean area. So here is our current tropical system that is out in the Pacific. It was Tropical Depression 16, but it has moved and it has begun to have some pretty good rotation with the storm, and it is just west of the Philippines. Just east of the Philippines, and thanks to that high pressure that is located off to the east a little bit, is going to force the storm to work its way north towards Japan. It's going to slide in between those two systems right around here. So as it begins to slide up into here, the Philippines looks like they will be out of the clear, and the Megi affected area of Taiwan and China should be in the clear as well. So here's some indices that we're going to be looking at with the shear indices, an area of 5 and 10 around the storm. So that is really not enough to break this storm up. And then as it moves north, it won't begin to see any shear that can tear it up until it gets towards the Japanese area. So right now, all bets are on that this storm is going to ramp up pretty quickly as it moves more north. So the Tropical Depression 16 is becoming better organized as it drifts across the Philippine Sea, and it's going to be recurving to the north-northeast as a lot of the models are predicting that it will do. So here's a current look at the warnings and watches across the United States. And if you will notice just to the south, all that yellow and red and orange, those are thunderstorm warning watches and tornado warning and watches. As we zoom in just a little bit, and we are going to take a look at some GR level 3 radar data as the area are being pretty heavily affected by hail, tornado, and some heavy winds associated with some mesocyclones. So here is the current SPC mesoscale discussion. As a short wave is working its way through the area, there is plenty of CAPE and there's plenty of what is known as storm relative helicity in the atmosphere to make some mesoscale cyclones. So if you notice that line I've drawn right through those contour lines, it's showing the trough that is finally dipped about as far as it's going to go south. In that area just to the east of that line is going to be the effective area as that short wave works its way through the area. Then here's our 500 millibar wind speed showing that exact same short wave. So basically we're looking at the RUC, which is the rapid update cycle, and it's when you're doing severe weather analysis, it's probably going to be your best model because it's continually run every couple hours to get the best possible models. Here are what is known as our surface CAPE, and the CAPE is the convective available potential energy, the energy that's available in the atmosphere to create storms. And we are looking at values of about 2,000 in parts of eastern Texas, northern Arkansas, 1,500 to 2,000 in southern Arkansas and northern Louisiana. So there is a lot of energy in the atmosphere for storms to be created over the next couple of hours. This is our 0 to 3 kilometer storm relative helicity, and helicity is a value we're going to look at when we're trying to find two possible things. A, the likelihood that there's going to be tornadoes, and B, the possibility of there being supercell development. And anywhere from 150 to 300 is possible supercells. Anything above 300 and up is a very good shot that you're going to see supercells. And in parts of eastern Texas, it looks like 350 to about 450. So definitely going to be some concern there for that entire area. Okay, so right now we are looking at our composite reflectivity from the Shreveport radar. And some pretty dangerous storms have popped up along with the system that we've been talking about for the last couple minutes. We're just going to swing through and actually look at a couple of the more dangerous ones. We're going to go ahead and zoom here into the northwestern part of Texas, just south of Boston, Texas, a little bit closer to Texarkana. And we're going to back off a little bit and get rid of these warning boxes. And watch this portion of the storm right here. This is one of the ones that they've tagged with a tornado warning. And we're going to slowly advance forward and notice how on that southern end you start to see that tail begin to develop. And basically you can see it really well right there, that little notch right here. That's from the wind coming in at this direction, coming in from the south. And basically that storm rotation is so powerful that it is wrapping some of that rain around. So the uplift of the storm is right here that I'm circling, and then it is circulating the rain and the rain and the hail around that storm. So we're going to go ahead and go to what we're looking at currently, bring those warnings back up, and then some tornado warnings along here as well. We'll pop up one of these boxes, and the National Weather Service has detected a severe storm capable of producing a tornado moving east at 45. And basically, there are some algorithms that are popping up on the National Weather Service radar. For example, the storm relative velocity that is showing them that there is most likely a tornado. Now, none of this has been confirmed on the ground, but again, they're seeing tendencies in the radar that are confirming that there could be a tornado on the ground. So we're going to look at the storm relative velocity. And basically how this works is anything that's red is moving away from the radar, and anything that's green is moving towards the radar. So if we go ahead and slowly move this forward, you can tell that a portion right here is moving to the northwest, and then this little notch right here is moving towards the radar. So we're getting a lot of rotation right in that area. And then we go ahead and look at the base reflectivity. You can see that little tail. Again, there's going to be some uplift, and then that small little portion is being sucked down. So they just issued another warning, and they're sort of giving a warning for what will be affected area of Ashdown, as this storm that we just talked about was affecting south of Boston, and now they're letting the people in Ashdown and all the smaller cities around here like Ogden and Wilton, let them know that this appears to be a tornado that is going to continue to develop as it heads their way. One other thing we have to be worried about with a lot of this is VIL, which is vertically integrated liquid, and that is going to show the amount of hail that could potentially be in a storm. And basically, once you get up into the grays, the whites and the grays, you know that you have about 80 kilograms per meter square of vertical liquid that could become a hailstorm. So a lot of these storms, this one right here that is just north of Mount Pleasant headed towards Omaha and Naples, not only does it have a tornado warning, but it also has a severe thunderstorm warning. And then the same goes for that storm we were talking about south of Boston that's headed towards Ashdown and Wilton. So we're going to change radars and go over to the Little Rock radar and show you some more storms over here as well. So they're getting absolutely hammered with severe thunderstorm warnings. So the biggest problems with these that we usually see are going to be hail and strong winds. So Pine Bluff had this storm move through the area. Pretty big hail maker just went through Cheryl. Wouldn't be surprised if they saw hail anywhere from golf ball size or a little bit larger. So severe thunderstorm capable of producing quarter-sized hail and damaging winds in excess of 60 miles an hour. And then the same goes for portions of Hampton, Warren, and Fordyce in southern Arkansas. Also probably saw thunderstorms capable of producing quarter-sized hail and 60-mile-an-hour winds. So the majority of these storms, though, with this system are moving from the west, obviously, into Arkansas, and a lot are still developing as the storms head towards Memphis, as the storms head towards the Mississippi-Arkansas border. So if you are in the northern Mississippi Delta, portions of Marks, Clarksdale, Tunica, Senatobia, Batesville, in that area, be on the lookout because strong storms are headed your way with this system. Same goes for portions of Memphis, where they are probably going to see severe thunderstorm warnings issued into western Tennessee over the next, I'd say, 30 minutes to the next hour, as these storms look like they're going to continue to strengthen. You can see some portions of storms right here just near Wynn starting to develop. That is definitely probably caused by an outflow of another storm as it develops and could potentially be devastating for that area. So we're going to keep an eye on this and continue to analyze some other stuff that's going on currently with the weather, more noticeably some snow out west and some high winds up in the northern plains of the United States. One other thing we're going to look at is the high wind watch for pretty much the entire state of South Dakota, southern Minnesota, Wisconsin, northern Illinois, and northern Iowa. As the low pressure digs into that area, and this is our 1,000 millibar low pressure, as that 1,000 millibar surface pressure, as that digs into the upper Midwest, it is going to bring in heavy wind. And here are just some of the wind forecasts. Wind speeds 30 to 35 sustained in Mankato, Minnesota. Spencer, Iowa, 37 to 40 miles an hour with gusts up to 55. Rochester, Minnesota, 31 to 34 with gusts of up to 55. So some pretty heavy wind along with that low pressure that will move through the upper Midwest by Wednesday afternoon. Well, this has been your October 24th, 2010 update. Thanks for tuning in, and be sure to check out the blog, website, and Twitter account for all the latest information. Have a great day.